Hello everyone, this is Amika Mahajan. Welcome to my channel. This video is focused on to draw electric field lines in different cases. First of all, I will consider isolated charges. First, I am taking positive charge. We know that electric field lines start from positive charge and end at negative charge. I will consider here negative charge to be at infinity. So lines will move out in all directions. So I will put arrows outwards. What I find, there is less gap between field lines near the charge, more gap between field lines as we move away from the charge. Denser electric field lines, stronger is the electric field. More separation between field lines show field gets comparatively weaker. Now we will draw field lines for negative charge. Here again same property I am using. That electric field lines start from positive charge and end at negative charge. Here positive charge is supposed to be at infinity. So field lines are entering the negative charge. So arrows will be inward. Again here we have to keep in mind that near the charge, less separation between field lines, and as we move away from the charge, more separation between field lines, showing that electric field is stronger near the charge. As we move away from the charge, comparatively field becomes weaker. If we have to draw field lines due to two unlike charges, consider two charges plus Q1 and minus Q2. I am considering magnitude different here. So the lines will start from positive and at negative. Here, these are the field lines due to isolated charges because these charges are in field of each other, as a result of which these charges are going to interact each other. And field lines, they will contract lengthwise. They will start from positive and end at negative like this. So this will be the shape of field lines in case of two unlike charges. Here, there are some regions where field lines are denser. It shows stronger field. But here are some regions where field lines are not denser. It shows weaker field. In case of electric dipoles, same type of field lines will be drawn, which we have drawn in previous case when I was taking two unlike charges, Q1 and Q2. The main difference is that we are not supposed to write Q1 and Q2 here. We have to write plus Q and minus Q because magnitude of charge remains same in case of dipole, polarity is opposite. Now come to two like charges. First, I consider both positive charges. If I consider isolated charges, field lines will be like this in case of isolated charges. But because these are positive charges, so arrows will be outward. But because these are charges in field of each other, so they will interact each other. Which property I'm going to use here? They start from positive and at negative. Here negative charges will be considered to be at infinity. But field lines, they exert lateral pressure, sideways pressure. So these lines will bend like this. It shows repulsion between two like charges. So these will be the field lines drawn for like charges. If I consider negative charges, same kind of field lines will be there, but direction of arrows will be reversed. Initially, both positive charges were there, so arrows were outward. Now arrows will be inward because in negative charge, the field lines will end. So this will be the case when we draw field lines for two negative charges. They are exerting lateral pressure. So these lines are bending. They are starting from infinity entering into charges because their negative charges are there. So arrows are inward. Here is a region in which no field line is there. So in place between these two charges, there will be point where electric field will be 0. Now in case of uniform electric field lines will be equidistant and parallel, and arrows will be drawn from left to right. I consider positive charge to be at left side. So these will be electric field lines in case of uniform electric field. Practice for such diagrams. Thanks for watching this video. Like, share, subscribe my channel.